Okay. Now, okay. Now, lastly, we described that how we identified the disadvantage or the demerit of push-pull amplifier, and we noted that though this push-pull amplifier gives you conduction for positive half cycle, okay, and this is negative half cycle. We call this push pull amplifier because Q1 was in conducting stage and Q2 was in non-conducting for first half cycle, and then things become opposite for the negative half cycle. But anyhow, with the push pull amplifier, the advantage is that we are getting what conduction for the two half cycles, okay, for positive and negative. But this disadvantage is that there is non-conducting areas, okay, which is over here and which is over here in this part, okay, which is known as cross or distortion. And that because of this barrier voltage, this barrier junction, which is 0.7, okay. So if there will be no IB or base current or base biasing at the base until a signal goes greater than 0.7. So it's just a question of providing a biasing, okay, over here of 0.7. So this is just a question of, okay, that if we can somehow provide a biasing for 0.7 over here and similarly as 0.7 in this region, only conduction for 0.7 volts, okay. So then if it happens that if we somehow, okay, provide conduction for, okay, for a biasing of 0.7, okay, okay, so what would happen that this distortion areas would get eliminated, it will go, okay, away, and we would have what, a continue equation, a continue waveform from here to here, and then we would have a continue waveform from here. So basically we would have a continuation like this, okay, a continuation like this, okay, okay, sorry, this is okay. So okay, the cross distortion will be eliminated. So what we do, we go and we modify this circuit, okay, which circuit, the push pull amplifier circuit. This was the push pull amplifier circuit, and we insert, okay, a small biasing, okay, DC biasing at the base, so that, okay, the amplifier also conducts for that, okay, for that region, okay, for that biasing, and that is 0.7 volts. So somehow, so we say that we modify push pull amplifier, okay, over here to a class AB amplifier, which is over here in this circuit, okay, by introducing what, introducing base biasing at the base. We can see biasing at the base over here, biasing at the base over here, okay, just to make sure that the both of the amplifier conducts, okay, and there is no cross distortion. So by introducing, how can we introducing that biasing at the base, okay, at this position, okay. So you can see we introduce R1 and D1, okay, at Q1 we introduce R1 and D1. So basically, and then at Q2 at the base we, okay, introduce R2 and D2, okay. So it means I have D1 two diodes, okay, two diodes, right, and R1 two resistors, R1 and R2 of equal value, okay. So if you see, this is a small DC biasing to overcome the 0.7 crossover distortion, right, okay. So the mechanism is quite simple, okay, the mechanism. So if I introduce, okay, this biasing, so what would happen actually, that both of, okay, the D1 and D2 are closely matched the characteristic of transistor base emitter junctions, right, okay. So basically it would provide, okay, a conduction, okay, okay, for that 0.7, okay, it would provide a conduction or biasing for, okay, exactly 0.7, because what is the barrier voltage of D1, okay, 0.7. What is the barrier voltage of D1? Remember, it was 0.7, Okay, so this configuration is going to bias or conduct, okay, this base emitter junction, okay, for this period of time, and similarly it can be explained for this part, which is PNP. Okay, now so the characteristics is we okay that this combination of R1 and D1 is going to address or is going to rectify, okay, crossover distortion somewhere over here, okay, for this positive sub over here, to be very precise. Okay, and this D1 and R2 combination is going to give you a drop, okay, and biasing, okay, a prior biasing, we call it prior biasing, okay, conduction biasing for this area, which is for negative half cycle, for negative half this area. So basically it means that now the Q1 and Q2 both are in conduction for these areas. Okay, now the next point says, so the first point is that there should be this D1 should have exact value of 0.7 to match this base emitter conduction. D2 must have a value of 0.7, okay, so to match this base emitter characteristics. Okay, now the voltage at point A between the diodes is equal to 0. Okay, is equal to 0, and that eliminates the need for an input coupling capacitor, right? Okay, now if you see, okay, now what does this mean? This mean that if this, remember this value over here VCC, okay, we are not proving that, but we will be just investigation and by just by looking into the properties. Okay, this VCC and this minus VCC both have the same values. This R1 and this R2 have both the same values. Okay, okay, now this D1 and D2 are both are similar. Okay, it means that the potential drop over here, okay, okay, at this midpoint, okay, over here, which is basically, okay, the midpoint for Q1 and Q2 transistors, this one, it would have, this point would have what, which is point A, they call it point A. Okay, it would have a potential, a certain potential. Now uh, now if so, if they are complementing each other, by complementing each other, that the value of plus PCC R1 and D1 is such that, okay, it produces a voltage at A, let's suppose that is x volts. Okay, x volts. Now so by symmetry, okay, this Q2 is complementary to NPN, R3 is similar to R1, and D2 is similarly to D1. So by symmetry, okay, this arrangement, okay, this is going to produce, okay, a voltage drop at a point A, okay, this one at point A, which will be equal to minus x volts. Okay, so this was x volts, okay, and this is minus x volts. Now remember the values are same, so x minus x volts will be equal to, let's suppose, equal to 0 volts, right? So it means that the voltage at point A would be equal to what is 0, because both are forcing to cancel each other. If this is a voltage at this point, which is equal to 0, but remember the voltage at this point, okay, there is some voltage over here, okay, and we call okay, there will be some voltage at this point, but I'm talking about this A, which is equal to 0. So the voltage at point A between it is equal to 0, and I told you the mechanisms that how this plus, how it becomes 0, and so there is no need of input coupling capacitor. So basically there will be no need of input coupling capacitor, so we can remove, that's why we did not attach any coupling capacitor over here. Okay, okay, now the drop, the third point said the drop across D1 equals VBE of Q1. So very straightforward. The drop across this D1, basically this D1 is equal to the base emitter junction voltage, which is 0.7. And similarly for D2 equals to Q2, and since they are matched, okay, they are equal and matched, the diode current will be the same as the ICQ. So basically it means that whatever they are matched, so anything IB goes over here or IB goes over here, okay, the resultant IC would be same for these two. So this is done. Okay, so by this arrangement basically the cross or distortion can be removed.